Welcome back to Ox Tools. I'm Tom. So what we got here is we got a cool little project, and this is a great project for beginning tool makers. And I say that because it involves some precision, some grinding, machine work, just kind of overall shop skills. But it's also I would say a forgiving project too. So, and I'll explain that a little bit more too. So, what we're building here, it's actually a training project that I designed, I don't know, quite a few years ago. Actually, I looked at my notes and I think it was 2016 or something like that. And what it is it's an adjustable, well, it's going to be a pair of adjustable V-blocks. So the idea is that maybe you have a shaft in the vise, or you need to change the attitude of a piece of shafting or a piece of stock or something like that, and you can set these up, and then it has an adjustment screw that runs the V-block up and down. Okay, pretty simple. So it's got some interesting operations on here. And we're making this out of tool steel, so there'll be some grinding and some heat treating and stuff like that. So it's a really good training project. So now here's the funny part is that I designed this and I've never made a set of these myself. So I figured you guys would appreciate going through that process and maybe making some for yourself. Now I'll make these PDFs available to folks that want to build their own. And that's all fine and dandy. So it's all been modeled up, and in fact I tweaked some stuff recently that I wanted to change. So got some stock cut here. Let's get down to it. Let's start on this and get going. 1/2 1.6. Sure, why not? So don't forget, when you're done with the piece, the leftover piece, be sure to just take that opportunity to mark it what it is. Now, I like to mark both ends, that way if I do forget, at least I have a second chance that I have a marked piece of steel. So if it's unknown, you got to treat it as unknown unless you're a one-man shop. So good habit to get into. The first thing we're going to do is, we've got these saw cut, and we want to just bring them down to our basic dimensions of the different parts. And what I like to do in this situation is, and I've already done one end here, I just kind of cleaned up one end from the saw cut. And then what I'll do with that is set a part up just loosely like that, and then set my stop like so. And that's why that has a flat blade screwdriver slot in it. So then we'll butt that properly now, clamp, and then we'll take a pass across there to clean it up. And I know I got a fair amount of stock on there. So what I'm going to do now is, without moving the axis at all, I'm going to take a measurement, and sometimes you got to get a little further out of the way, and we'll just do a caliper one here. So I got 1 inch 5/24, and our number is 1 inch 1.5 is what we want. So what I'm going to do is actually I'm going to plug this number 1, 2, 5. Preset. Okay, make sure I'm going the right way. Yeah, okay. So I plugged that number directly into the DRO, so now I can follow the DRO right down to my dimension. Now, one nice thing about this particular project is that none of this is like super hyper fussy, okay? There's only one fit that really requires some care, so and you get a couple chances at it, is what I'd like to say, and we'll talk about that later. So let's go ahead and get these to length and get all the rest of these pieces to their nominal lengths, and then we can start doing some real work here. This is a pretty efficient way to do this if you got a bunch of pieces to kind of size up here. And you shouldn't be afraid of climb cutting. It just doubles your opportunity to remove material. Okay. And I'm going kind of gentle here. You know, I could probably take this all off on one whack, but no particular reason to do that. Okay. Okay, so move on to the next one. These blocks here, I need to take this this distance down here, and I'm going to do the same thing on this. DRO trick here is I'm just going to I'm going to zero the quill DRO on the parallel. Oops. What I want to do is run that one in and make sure I've got a good zero. Yeah, it looks good. I'll touch a few places here. So now I'm reading 0 on the top of the parallel, and when I come up, my quill DRO actually reads the dimension that I'm looking for. Okay, so another little trick to speed up these kinds of operations where you have multiple things to do, and you can spend your time milling or you can spend your time measuring, depending on how you want to do it. roughing end mills really just mow this stuff off. It's a great way to use less horsepower to remove material too. There's just a lot of surface area on these cutters. So I'm going to lay out the V's and the notches on this and then I'll bandsaw some of that material out of there and then mill up to the lines. So this is just helpful when you have a feature that you have to locate. All right, so what's the next one? 450. You know, when you're removing some material, so I like to do this. Just helpful. Helps me make less mistakes. Let's put it that way. Right. All right. So that's the bottom. That's the bottom. We're going to come up 480 right there, and that's our center bit there. Sure, I'm in the right spot. Okay. Yep. Okay, and then yeah, so I think we can put the angles on it now. So what these are, I marked the intersection with that edge where the 45 breaks out onto that edge. So we're going to use this little magnetic block. This thing's pretty cool. Check this out. It's an old Brown and Sharp magnetic block, but it belonged to the Curtis Wright Corporation. It's marked. It was part of their inventory. I got it off eBay. I thought that was cool. I really kind of enjoy when there's those kinds of marks on things. So, all right, so we're going to put that there like that. And drop that in. I'm going to turn Mr. Magnet on. Oops. Hey, it helps if you put it on the right side there, dopey. That's the magnetic side. Okay. All right, like so. Alright, and then I'll get a line going here. I'm going to get my magnifier because I'm old and blind. I should be able to just flip this little... Oop. No. Oh, yeah, duh. Like that, I should be able to just flip it over, right? Get symmetry there, yep. Alright, looks like I didn't quite go far enough on that. Actually, I probably don't even need the magnet. Okay, so there's that. And what the hell's going on there? Oh, retard. Wrong set of marks. Alright, what that means is, gee, did I do that wrong? 1.5. Oh, I did do it wrong. Although I still need that. See, this is what happens when you're trying to shoot video and you're not paying attention. I still need that that mark. I put this mark in the wrong spot. That's what I did. That was 480. Let's go back to that one. In a lot of cases, you know, bandsawing out a bunch of material like this is much faster than milling. Now, on a couple small pieces like that, like this, it's a little bit questionable. So, you know, this material that I took out of there, right? These are the pieces. In retrospect, I probably could have milled that out just as fast. So, yeah, you know, 6 of one, half a dozen of the other. But as the sizes go up, this thin blade uses a lot less energy than plowing an end mill through there. So there's big sections to chop off. You can gain some big advantages by bandsawing. In this case, probably not a big advantage. It's probably a wash. But now we got it, and let's go ahead and we can stack these up, and well, not like that. Like that, and do a little milling on them and clean those sides up and get this thing going. The bozo check. So you see I'm working both sides, so I'm working about the center line here in this case, right? So equal distances each way for symmetry purposes. So I'm going to take a quick measurement here. There's a piece that fits in here that, okay, yeah, we're still fine here. So once again, you know, it's supposed to be 750 wide, right? So if you're a little wider or a little under, probably doesn't make a difference because you're going to make the piece that fits in there. And that's what I mean is this design is fairly forgiving. There's chances to, you know, you don't have to hit everything dead nuts if you don't, right? Things happen. We all understand that, right? All right, 180, let's go 185. Climb cut. Oops, 185 climb. So what I'm looking for here is I'm looking for a blend between that surface and that line intersection. And this is actually fairly sensitive when you have an angle there. This particular angle is not anything super precision or anything like that. It's just a, you know, kind of a little bit more. This is the clearance for the hand wheel underneath. So we'll leave a little on there to we want to grind all these surfaces so they look really nice too. That's the other thing. Okay, so we're just milling them, getting them close, and then we'll clean them with the grinder. Okay, so now, because of reversal and symmetry here, I should be able to just pop this loose. Make sure I'm clean. And pop this in the other side like that. Okay. Double check, make sure I'm not doing any bozo moves there. Okay. Come over here. And mill with impunity. In fact, I'm just going to do it all in one whack here. Alright, then we'll do the other side. Ooh, look at that. Oh, there's a bozo waiting to happen there. See that? That's like really close to that corner there, so I'm going to pull it down on this side here. Make sure that I'm touching in the corner and on this nice flat here. Okay. Feels good. Okay, good. Just got to get close on this one because we're going to put a grinding relief in that center, so I don't have to touch the other wall. In this case here, just going to make sure I'm pretty close. I am. Okay. There we go. We're going to put our grinding relief in there, and I'm just using this to even these two pieces up. Okay, and then what I'm going to do is I'm going to use an edge finder here. That's going way too fast. So what I want to do, I'm going to use the centering function of the DRO. So I don't even have to measure the piece to find the center or anything. The machine's doing, or the DRO's doing it for me. So whatever's there plus half the diameter, I don't even have to think about the diameter of that. I use the center function, okay? And when I come back to 0, right there, that's the center. So, you know, so if this is 2 inch and 5/1000ths or something like that, then it doesn't really matter because I'm in the center of the world there. If that makes sense. Okay, there's our little, we're going to put a grinding relief right there. Some folks asked about this previously. This is a Harvey tool end mill extension, and this is an older one here. It's tapered. The new ones don't quite look like this. I've had this one for quite a while. So it's got a 1/8 collet here and a draw screw, 1032 draw screw, 1/2 inch shank. So it allows you to kind of reach down into some of these areas with small tools that are normally kind of hard to get to. So they don't sell the tapered one anymore. There it is right there, part number 810, and it's a 1/2 inch diameter shank, Harvey tool. Harvey makes some pretty nice stuff. They don't give those away, by the way, if you go looking for them. Okay. And you know what? I'm going to bring you in close to the action here because this is just a itty bitty little tool. Now let's wind this thing up a bit. 2,000 RPM. And we're zeroed. Yeah, we're zeroed. Can't see the other side. Oh yeah. So what I was looking for, just so you know what I was looking for there, is I was looking for an equal mark on both sides. That tells me that I didn't, well, gives me some confirmation that I didn't screw something up. Let's just use air on this. Compressor might kick on, so I'm going to apologize ahead of time for that. So this allows me to get in next to that wall with the grinding wheel and get that whole area nice and flat. Yep. Crystal ball was accurate. And that really looks like enough to me.